may already exceed the limits of human intelligence. In 1880, French mathematician Henri Poincaré systematically studied the motion of three celestial bodies of equal mass. He discovered that three-body systems inherently possess chaotic characteristics. Even the simplified, restricted three-body problem, where celestial bodies move in or near commensurate orbits, is extremely complex and highly uncertain. Therefore, he asserted that the three-body problem has no exact solution. Poincaré's discovery made humanity realize for the first time that the universe is not a cold clockwork machine, but a stage full of uncertainty and chaos. In the winter of 1961, American meteorologist Edward Lorenz was simulating weather with a computer. He only wanted to save time, so he re-entered a previous set of data. But he cut corners and did not input all the decimals, keeping only 3 digits after the decimal point. For example, instead of 0.506127, he entered 0.506. He thought such a tiny simplification was insignificant. Yet the curve the computer generated was completely different from the previous one. This discovery left him stunned. He realized that the atmospheric system is extremely sensitive to initial conditions. Even seemingly negligible decimal differences, when projected over long periods, can be amplified and ultimately lead to completely different futures. In reality, humans can never determine all initial conditions with infinite precision. Therefore, weather prediction is inherently limited. People later called this phenomenon chaos, and Lorenz thus pioneered chaos theory. To vividly explain this sensitivity, in a 1972 lecture, he said the famous line, "A butterfly flapping its wings in Brazil could cause a tornado in Texas weeks later." This is the origin of the butterfly effect. In daily life, this effect is everywhere. For example, a small change in a person's marriage could ultimately affect the whole of human society. If you choose not to marry, your would-be wife might marry someone else, setting off a chain reaction that affects the composition of future generations. The three-body problem tells us that not all motion can be locked down with equations. In the future, even the interaction of just 3 stars can result in trajectories that change endlessly with the slightest disturbance. On a larger scale, the universe itself is a vast multi-body system. The gravitational pull between galaxies, the role of dark matter and dark energy, and even quantum-level uncertainty all seem to constantly remind us that the operation of the universe is not entirely predictable, but always evolves